Hi everyone, this is General Rajiv from PhD Expertise. Today we'll be talking with our special guest, Dr. Akanksha Menon. Dr. Menon is an assistant professor in the mechanical engineering department at Georgia Tech. Her research focuses on technologies for the energy water nexus. She was a postdoc fellow at the Lawrence Berkeley National Lab. Prior to that, she completed her master and PhD degrees in mechanical engineering at Georgia Tech, where I had the opportunity to participate in various activities of the Energy Club with her when she was the club president. Welcome to the program.
Yeah, thank you for the introduction and thanks for inviting me.
I'll kick off with the first question. Can you talk about your major research projects as a PhD student at Georgia Tech?
Yeah, so I was actually the first student in my group. So it was a brand new research group. And so that made it quite interesting the first couple of years because I had to like build the lab in addition to like working on my own research project. So that gave me a little bit of different experience. But my specific research project was focused on doing waste heat recovery and direct conversion of that heat into electricity. And I was doing this using thermoelectric generators. And so these are, it's not a new technology. It's been around, I think, like from the 1940s, 1950s, but all of those used inorganic semiconductors, which are high cost and only work for high temperature applications. So when looking at waste heat, we realized that more than 60% of the waste heat is at low temperatures. So what we need to do is to develop technologies that can capture waste heat at these low temperatures and at a low cost. And so I was working on developing conducting polymers. And it was actually a nice project because I got to do a lot of materials synthesis or polymer synthesis, which was completely new to me, right? And ME, we don't necessarily do a lot of materials work. So this way I got to do some chemistry, but at the same time, I could also look at like, how do we design these devices thermally to maximize the power output and actually build a prototype. We worked with the chemistry department to really fine tune the synthesis. And most of what I did was measure the thermoelectric properties and then build a device prototype. And one cool thing was because the polymers are flexible and can be printed. So I also did some work on integrating them into textiles. And so the idea here is we can make smart textiles, which can use your body heat to produce electricity. So imagine you put, your Fitbit with this thermoelectric material, it'll use your body heat and it can charge your Fitbit, or you wear a t-shirt with a pocket, you put your phone in there and it can be charged with your body heat. So there were these some really cool ideas for wearable electronics, flexible electronics that came out of this work.
Oh, I see. So following your PhD at Georgia Tech, you went to Berkeley National Lab. Can you talk
Mhm.
about some of your goals as well as your research areas?
Yeah, so when I wanted to do the postdoc at a national lab, I also wanted to work on something different, just to get exposed to like a different research area, but still broadly within thermal science and energy, and still some materials work. So I worked actually on desalination, so solar desalination specifically, and this was in Dr. Ravi Prasher's group in the energy technologies area at Lawrence Berkeley National Lab. So what we did was design these photothermal converters. So it takes in sunlight, converts it into heat, specifically in the infrared, where water has a very strong absorption. So by doing this, you can really increase the temperature at the surface of water, which gives you much higher evaporation rates, which is one of the most common ways in which you do thermal desalination. You evaporate the water. So we're able to really increase the evaporation rate to do desalination. And then I also worked on developing like a combination of a membrane and a thermal desalination system using some ionic liquids. So these materials are really cool because at room temperature, they just mix with water, but as soon as you start heating them up, it'll phase separate from the water. So you get a liquid-liquid phase separation for desalination. And then being at a national lab is nice because you get exposed to a lot of different projects. I also was able to get involved on writing a proposal on thermal energy storage. And this we were looking at similar to having like lithium ion batteries to store electricity. We're looking at how do you store heat for heat. So instead of burning natural gas in a building for heating or hot water, you could use thermal energy storage. So you can decarbonize the heat. So all of that was the work that I did at Lawrence Berkeley National Lab, looking at desalination and some thermal energy storage.
Okay, yeah, no, that's really helpful to hear, and it gives us some context about what happens next, and that is you become a professor at Georgia Tech. So could you talk a little bit about when you made that decision that you want to go the professor path, and then why Georgia Tech?
Yeah, so I think the academic route is always something that I aspired to, and that was like a big motivation for going to graduate school. Actually, throughout graduate school, I realized, okay, I really like doing research and trying to find these solutions to open-ended problems. But what I wasn't sure about is, do I want to do research as a research scientist, or do I really want to become a professor? Especially because I worked like in a startup lab. So I saw my advisor really, like the amount of work he had to put in to really get things off the ground as a new professor. So that's why I really did the postdoc at a national lab, because I thought, okay, maybe I will see what it is like to do research at a national lab as a staff scientist. And there's a lot of similarities between doing academic research or working at a national lab. But what I realized was that I really missed the mentoring aspect. So you don't get to work with students the same way that you do in a professor position, right? And also you don't have the same level of independence because you're working in much larger teams with like multiple PIs. And so that's when I knew that I definitely should apply to faculty positions. And Georgia Tech, of course, was like a no-brainer because I loved my time here as a student. So to come back and give back in a sense would just be really, really exciting. And also, like the work that I do is heat transfer and energy systems, and that's one of the best known programs is here at Georgia Tech. And so really to be able to get high quality students or access to high quality facilities to do the kind of research I wanted to do, it was just a no-brainer to come back here. You should ask Georgia Tech why they brought me back here.
Well, it's already obvious to us just listening to you. So no, that's really interesting. And so for your, there's a broader application process that you probably went through. Can you share some details around what that was like and what people should expect going into an application process for professorship?
Yeah, of course. So it's pretty standard across most research universities. So you have to have a research statement. This is like the most important document where you're basically talking about all the work you've done so far, but you're also trying to show your research vision, right? So like 5 years, 10 years from now, what is your research program going to look like? So you curate that vision. This is typically like a 3 to 5 page document. And then you have to submit a teaching statement. And this is where you talk about any teaching experience you've had, and then also mention what new ideas you may have for teaching. Again, if you're applying to a very research intensive university, you don't need to spend a lot of time innovating on the teaching side. You just talk about classes that you would like to introduce. Whereas if you're applying to a more teaching focused university, then you really should come up with new methods to improve learning or student engagement. So that's like a 2-page document, the teaching statement. And then now it's becoming pretty common to have a diversity and equity statement. So you talk about different activities you've been involved in from being a student, postdoc, whatever it was, where you contributed to efforts to improve diversity, equity, inclusion. And then you also share how you would do that in your classroom, in your research group, and just broadly as an individual at the institution. So those are the 3 main documents that you require everywhere. And then, of course, your CV is pretty important, right? Because that's where you list all your publications, and then a cover letter at some places.
Okay. And how long in advance did you start getting prepared for this change?
Yeah, so the academic, the big call for most universities comes out every fall. So around October is when most places put out their job postings. So it's really important to prepare that previous summer. And so in my case, that was the summer of 2019, actually. So that summer, I spent a lot of time just trying to figure out what is that research vision going to look like. That's the hardest part, right? Once you have your 2 or 3 ideas that you want your group to work on, writing the document is easy. But coming up with those 3 ideas and why you're the right person to do that work, that's the hardest part. So I had multiple drafts that I wrote and then just tossed because I just wasn't able to bring it together. And then probably, I think, like 30 days of really persistent thinking and writing, that's when I was able to get that research statement together.
Okay. And you said 2 years ago is when you started thinking about this, and now you've joined as faculty.
Yeah. So I think maybe that's a little bit unique, and maybe that happened because of the pandemic. So, but I think I was lucky in that sense because I applied in fall of 2019, and so I was actually able to do in-person interviews at most of the places. Yeah, because typically interviews are in January and Feb. Some places start as early as December, but Jan, Feb, March is pretty typical. So I did a lot of travel in Jan and Feb, and then my final trip was like March 6th. And I remember coming back to the airport after that trip, and I saw people wearing masks, and I was like, what's going on? It was very, very naive in retrospect. And then everything shut down. So I guess I'm really grateful that I was able to interview in person and like interact with people that would potentially become colleagues, right? I think that's harder to do virtually.
Yeah.
So that part, I'm glad I could go, and you could actually like see the campus. All of that is also important because it's a place you're going to be living in. So you want to get a sense of the city as well. But what happened was I did all the interviews. So that part was great. I got to go in person, but right after that, COVID hit. And so all the budgets were frozen.
Oh, okay.
Yeah. And so none of the schools were willing to make offers. And so because of that, the timeline got really delayed. So normally, by April, you would find out, and then you start that fall. But here, because nobody knew what was going to happen, it took a lot longer. So most of the offers started coming through only later in summer. And some schools just canceled the search completely after candidates had interviewed, which is really unfortunate. But I think luckily the 3 places that I went and interviewed at were all able to make offers to me. But because it came so much later, there was no way I could start in fall itself. And so I just deferred and started this semester instead.
Okay.
Which also worked out because it gave me some more time to prepare.
Yeah, I know. I mean, that's an incredible story. That's like resilience and all sorts of things you've had to go through, but it's a great opportunity. We kind of going into our next topic. It's really more technical things that we wanted to ask you that people ask us sometimes too. And so the first question is it's around climate change and the threats to security of our energy and water systems, right? What specific challenges do you think climate change imposes on the energy water nexus?
Yeah, so I think the obvious one that we're seeing is that climate change is changing our water resources. So for instance, like in California, we're so used to hearing about the droughts, right? So that's something that part of the country is used to. But what the projections actually show is that by the end of this decade, so by 2030, like about half of the global population is going to be living under severe water stress. And the reason for that is because, climate change has changed rain patterns. We have hotter days than we ever have had in history, right? So all of this has impacted like our natural water resources. And it's not just water for like drinking purposes. It's also water that's it's such a critical resource for so many things. So the whole idea of this water energy nexus is that water plays a very important role in, for example, like oil and gas extraction. So one of the things I learned during my time at Lawrence Berkeley was that for every barrel of oil that you're producing, you have about 10 barrels of water. So that's a scale, right? And if we look at the Middle Eastern countries or even in Texas, just they produce like millions of barrels of oil a day. So the amount of water that's used is, just crazy. And then same way, even for power generation, right? All the electricity, our grid is still largely from just traditional thermoelectric power plants, all of which are cooled with water. And so that's what this water energy nexus kind of indicates, that water is so important to energy production. And then in order to treat water, you need a lot of energy. So they're very like interdependent resources. And so the goal and some of the work that I've started here is really how do we try to get to this circular water economy, meaning that you recycle and you reuse water. Also try to do this with renewable energy, right?
Yeah, no, and that makes sense, and it's certainly a large problem that needs to be solved. So I'm glad you're taking steps to start working on that. And then going into sort of the reducing energy usage, I think that's a part of this topic too. It's in water treatment and water infrastructure.
Mm-hmm.
We saw that and you talked about it a little bit. This Nature sustainability paper that you had on enhanced solar evaporation.
Mm-hmm.
What kind of innovative things do you think are happening now in this space that'll help reduce energy usage in water treatment, water infrastructure?
Yeah, so that field has actually really, really taken off. If you look like over the last 5 years, there's hundreds of papers on increasing like solar evaporation using very simple methods. So what I had in the paper we called a solar umbrella, because you just keep this photothermal converter on top of water and it really enhances evaporation. So the big thing is it's not just important to reduce energy use, it's important if you still need to use the same amount of energy, at least that energy should be clean or sustainable.
Yeah.
So there's those two aspects, right? So reducing the water, the energy use is a little bit challenging because that's determined by just how much salt is in the water. So that we can't control as much. But what we can do is use cleaner, more sustainable forms of energy. And so that's where this whole coupling with renewables, whether it's solar, wind, or even geothermal, right? Geothermal energy, you could have a water treatment plant connected to it, or waste heat. All of these industries produce a lot of waste heat. You can use that heat to run a water treatment plant, so you're not using new energy sources. But the other thing is actually one of the biggest consumption of energy in water is the amount of energy we use to transport water. And so instead of having these like large treatment facilities and then transporting the water over long distances, because water is actually pretty heavy, you could look at distributed water systems or distributed desalination. So you have these treatment units closely co-located with an industrial plant or close to like a population center. So then you're not losing a lot of energy just transporting water.
Yeah, that makes sense. So it's not just an innovation question, but it's also just like a practicality of where you place things question too, right? Mm-hmm. Okay. All right. No, that's super helpful to hear about. And then our final question on this topic is basically there's an interdependency between these energy and water systems that we've talked about.
Yeah.
What are some of the technical and regulatory opportunities that you kind of see that are closest to us now? So I think one example you gave, it's not necessarily a technical innovation, but putting facilities closer to population centers, right? But there's obviously regulatory challenges in doing those type of things. There's funding challenges. What do you have any thoughts on those topics?
Yeah, so actually, I mean, the good news is that companies have started to realize that it would benefit them to have water systems co-located. So for instance, I've spoken to like Southern Company or Georgia Power. They produce a lot of electricity, obviously, for the state, and they also have wastewater from their cooling tower blowdown. But then they need clean water for their condensers. And so they see a huge opportunity in, okay, taking that cooling tower blowdown, treating it right there, and then reusing it in their condenser. It saves them a lot of infrastructure and really gives them, this independence to do their operation. Because to try and dispose a lot of wastewater, that's also very challenging from a regulatory perspective. And more regulations are coming in place, which is why companies are now thinking about, okay, what do we do with our wastewater? So I think regulations environmentally are definitely going in that right direction, which is forcing companies to think about ways to get creative about reusing their water. But yeah, I mean, ultimately, it's really not one size fits all, because the technology tends to be very dependent on what the water quality is. So it's not trivial. And that's why it's taken a long time to try and get to this shift. But there is DOE funding, actually. It's called the National Alliance for Water Innovation, or NAWI, which it just happens to be headquartered at Lawrence Berkeley National Lab. But this was started just last year to really focus on this distributed desalination concept. Yeah, so I think that's also going to help push policy and technology innovations in this space.
Okay, yeah, I think both will have to go hand in hand unless if we want to drive change. So that's great to hear too.
Yeah.
To have a quick follow-up question, you gave the example of the Southern Company as well as Georgia Power, as well as the U.S. DOE funded the project. Do you see more funding coming from the government than the industry, or about the half-half mix for the energy water nexus challenges?
Yeah, so the thing is, industry wants technologies that are pretty well proven, right? So they want you to be almost, pilot scale demonstration, then they're willing to work with you. Whereas if you're trying to do proof of concept demonstration, they're hesitant, and rightfully so, because that's higher risk, right? And so I think the DOE or the federal government really has a role to play for those earlier stage technologies. And then industry comes in once you're at a higher technical readiness level or higher TRL. So I think both go hand in hand. The DOE also, what they've started doing now for a lot of projects is they require what they call cost share, which means industry has to buy into your project. So they're really pushing to have academic, national lab, and industry partners together on a proposal. So I think that, again, will really help industry also become more comfortable with funding some earlier stage research.
That totally makes sense. There's a risk reward element that we have to consider here. So appreciate that. We're out of time, but we want to thank Dr. Akanksha Menon for being with us today. This has been a really informative conversation. And if you have any questions for Dr. Menon, please contact us at phdexpertiseteam@gmail.com. And we'll get them over to her. And until next time, thank you for joining us today.
Great. Thank you.